In this video, you will learn how to analyze and solve some linear programming problems. So let's solve some. Alright, we're given this problem here on optimal revenue. An accounting firm has 900 hours of staff time and 155 hours of reviewing time available each week. The firm charges $2,500 for an audit and $350 for a tax return. Each audit requires 75 hours of staff time and 10 hours of review time. Each tax return requires 12.5 hours of staff time and 2.5 hours of review time. What numbers of audits and tax returns will yield an optimal revenue? What is the optimal revenue? So we are asked here to look for the optimal or the maximum value. We don't know the number of audits and the number of returns or tax returns. So we can let X be the number of audits then Y be the number of tax returns. Now let's create a table here first so we can write our constraints and the value that will be maximized, or the optimal value, optimal revenue. So we have X for audits and then Y for the returns. And then, okay, so we have here staff time or staff hours and then review time or review hours. So staff hours, review hours, and then the revenue in dollars. All right. So for audits, it says here each audit requires 75 hours of staff time. So that would be 75 hours. And then 10 hours of review time. And then for tax return, it requires 12.5 hours of staff time and then 2.5 hours of review time. And then for the revenue in dollars, it says here that the firm charges $2,500 for an audit. So this would be $2,500 and then $350 for the tax return. So this is the value that we're going to maximize. So from here, okay, from our revenue in dollars, we can write our objective function. Okay, objective function Z. If you can still remember from the previous video, it's in the form Z equals AX plus BY. You can use Z or any variable you want. You can use R for like a feasible region. So our objective function equation will be this one. Okay, so this is just $2,500 times X, because we don't know the number of audits, plus, okay, let's just omit the dollar sign, $350 times Y equals Z. And then we can write our constraints from here. Oh, I forgot to Right here it says an accounting firm has 900 hours of staff time. So it should be at least 900 hours, and then at least 155 hours. We can write our constraints here. So from here we can write 75x plus 12.5 y less than or equal to 900. That's one of our inequalities. This is for the staff hours. And then for the review hours or review time, it will be 10x plus 2.5y less than or equal to 155. And then we don't forget our non-negative constraints. It would be x greater than or equal to 0 and y greater than or equal to 0. And now we can graph. Okay, let's graph all the inequalities. This one here. So we can find the corner points. We will use corner point method. Or we can find the corners or the vertices. And those vertices, we will use them to look for the maximum value by plugging in the values of x and y to our objective function. All right. You take note of this because I'm going to delete. All right. So let's graph this. We have, okay, x greater than or equal to 0. So this is our x-axis. So all of the values above x, or x is included. So all of the values here. Then y greater than or equal to 0. So this is our y-axis. So all of the values, including y, positive values. Then we graph this one, 75x plus 12.5y less than or equal to 900. So we can assign values for our x to solve for y. Let's say our x is 0. When x is 0, then y is equal to 0. So this is 0, 0. And then when x is 12, there is 12 here, 12, then y is 0. So this is 12, 0. And then when x is 5, 1, 2, 3, 4, 5, y is 42. So let's say this is 5, 10, 15, 20, 25, 30, 35, 40, 45. So this is 40. So when x is 5, y is 42. It's somewhere here. 5, 42. And then when x is... Alright, so we won't be confused. Let's plot the straight line first. Okay, let's delete this. So we plot... We can write this as 12.5y equals negative 75x plus 900. Then we divide by 12.5y, 12.5. So y is equal to negative 6x plus 72. So the slope here is negative 6, and then we can also rewrite the other equation, the other inequality, this one. So you can write this as 2.5 y equals negative 10x plus 155 over 2.5. So y here is just equal negative 4. So our slope is negative 4. Negative 4x plus 62. Now we can graph this. So when x is, for the first one, this one, when x is 0, y is 72. So if this is 5, 10, 15, let's start with 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So 0 would be here. So this is 0, 62. Alright. And then when x is 1, okay. When x is 1, y is 58. So should be somewhere here. 58. So this is 158. Right. And when x is 15.5, let's say this is 15.5 here. Be 0, 15.5, 15.5. So y is 0. So 15.5. So now we can have our first line. It's not that accurate. Oh my. Let's say this is our line. Alright. So this line is 75x plus 12.5 y equals 900, or y equals negative 4x plus 62. It says less than or equal. So all the values here below the line, including the line below the line. Alright. So let's graph the next inequality or line, y equals negative 6x plus 72. So when x is 0, y is 72. So this is 65, 70 here. Should be 0, 72. And then when x is 1, y is 66. So maybe somewhere here. And then when x is 12, y is 0. So somewhere here. 12, 0. And then when x is 5, y is 42. So 5, 10, 15, 20, 25, 30, 40, 42 is somewhere here. So our line would look like this. It's not really that accurate. So say this is blue. Alright. So all of the values below this line. So now we get our feasible region. Should be this region here. This one. Okay. I don't know. Here. So we can get our vertices. This is included here. This region. So our vertices would be 0, 0, 12, 0, 5, 42, and then 0, 62. And now we already have our vertices or our corner points. Then we can use the corner point method and substitute all of these values to the objective function. And the highest value there would be our maximum or optimal value. So let's do it. Okay, when x is 0 and y is 0, z is equal to 0. When x is 12 and then y is 0, then z is 30,000. And then when x is 5 and then y is 42, then x is 27,200. And then when x is 0 and y is 62, we get 21,700. Okay, therefore our optimal value or revenue is $30,000 at 12.120. So our answer is $30,000. So the revenue will be optimal at 12 audits and 0 tax returns with a value of $30,000.